Okay, so this video is all about finding the area of polygons, different two-sided shapes, applying those rules that you've learnt so far, Heron's formula, sine, or the SAS area rule. But before we do that, we're just going to do a quick look at converting into hectares. Now, hectares is an area unit. It is 1 hectare is equal to a square that has 100 metres on each side. So 1 hectare would be a square that is 100 by 100. And so the area would be 100 times 100, which would be 10,000 square metres. So we normally use hectares to measure land, and so you might, in problem-solving questions, be asked to convert your answer into hectares. So you will just need the conversion factor of 1 hectare, that's not a good one, is equal to 10,000 square metres. So you should do the couple of questions that you've got there on the area of polygons PowerPoint, just to practice converting into hectares. And then come back to the video and we'll have a look at splitting shapes up and finding the area. Okay, so to find the area of a polygon. So a polygon is a closed figure that has 3 or more normally straight sides. So just like when we do area of composite shapes, we can just break these up into regular shapes that we know. We can break them up into triangles, trapeziums, rectangles, squares, that kind of thing. The challenge for you then is to identify the rule that you need to use given the information that you have on the shape when you divide it. So these polygons, you can see, because they're all straight sides, we can divide straight into triangles. Okay, so first step is to divide it into triangles. So you can see over here, we've just put this dotted line and this dotted line to make 1, 2, 3 triangles. Then you find that the area of each of those triangles separately, and then you're going to add them together. Okay, so let's have a look at an example. So these sorts of questions are complex routine. Complex because you do have multiple steps. This one in particular isn't very complex and may be done as a simple, even though it will be 4 steps, but that's because 3 of the steps are the same. They're using the same rule. It's just a repeated simple routine. Okay, so to begin with, we need to make sure that because it's a modelling and problem-solving question, a map question, we need to identify what we're doing as we do it to show our strategy. So I'm going to find the area of, so it's going to be area 1, triangle AED. And so to do that, I have a look at what information I have, and I can see that I have 2 sides and an angle. Now that means I can use my SAS area rule. So that's half AB sine C. And so that's going to be a half times 225 times 325 times the sine of 30. So if I calculate all of that together, I end up with 18,281.25 metres squared. So if we just have a quick look at our criteria for this, so far we've got M1 just showing our problem solving strategy, and then writing our rule is our K1M1. So it's still showing our strategy by showing the particular rule or formula and the way that we're going to work that problem out. This one here is going to be, oh, that's a terrible K, K2, and then this one here, K3. Okay, our next step, we're going to find area of triangle ADC. Now, if you actually look at each of these triangles, each one of them has two sides with the given angle between them. And so we will be using sine ratio rule for all of them. So area 2 is going to be half AB sine of C, which is going to be a half times 325 times 320 times the sine of 40. It's a terrible 40. Let's just redo that for. Okay. Which, when we calculate, is 33,424.9557 square meters. Now, I'm not going to round anything yet. Because this is a multi-step question, I really don't want to round until the very last step. Okay, so I'm just going to move some of these up and around, up and around. Okay, so next, we're going to look at the third triangle. So area 3, area 3. We're going to do area of triangle ABC. Okay, so area 3 is going to equal, again, because we have that same information, half AB times the sine of C. And so that's going to be a half times 320 times 250, they're the two sides, by the sine of the angle, which is 20 degrees. And when we put them all, multiply them all together, we get 13,680.80573 square meters. Okay, so finally, if we just move them along again, finally we end up with the area of the polygon. I do apologise, this is a little bit messy. I don't actually have my stylus. Okay, so what we're finding is the total area. And so that will be area 1 plus area 2 plus area 3. Now, just like we did before, and I showed you on the first step, but not on those subsequent ones, we need to make sure we're actually identifying what we're doing. So this one here is showing that we're finding the area of the entire polygon. And then down here, this is our M1K1, where we're showing that rule and what we're actually doing. It is important that you still write a rule for every step when there is a K1 or an M1 attached to it. So basically, we just sub in the answers that we got for each of these. So I would just, go back and, oh, that's a 4, 0.9557, and our last one, 13680.80573. There we go. And I add them all together to get 65,387.01143. And so because this is land area, it's a lot of these questions will be attached to the shape of land. We're just going to round that to a whole number, and especially if you have a look here, Because this here is 0.01143, it's a really small amount over, so we're just going to round that to a whole number. That seems a lot more reasonable, and we're going to make sure that we write meters squared. Now let's just move them up slightly. Finally, we can do, therefore, the area of the polygon is 65,387 square meters. Okay, so let's have a look. We know we have M1 and K1 in the beginning for this one. This one here, because we're calculating, is K2. Down here we have K3. This one, because we round, is C1, and then we will also get C1 for, using those correct units, and that's also where you would lose your communication. And then down here, our concluding sentence, M3. See how it refers back to the question. This question was a really simple one, the area of the polygon, but a lot of the time it will be things like the area of land. And so you need to make sure that one refers back to the question that you were asked about. Okay, so we've got one more to have a look at. Now, this one, I'm not actually going to do a full working for. I will go through that in class if you are confused. But what I want to show you is that sometimes it's not always about breaking them into triangles. So this question, you can see we've been able to just split straight down here, and that gives us a triangle with 3 sides. So we can actually use Heron's formula to find the area of that triangle. And then here we have a trapezium. So if you turn it to the side, you can see this would be A, this would be B, and we have those two. And we have the height, because they're right angles there, that is the perpendicular height. And because the formula for a trapezium is half A plus B times the height, we have all of the information we need to do that. So you have to remember, when you are breaking these, when you're breaking these shapes up, you have to make sure that the shapes you break them into allow you to still have enough information to find the area. Don't forget also that sometimes you can actually use Pythagoras in order to find a missing side if you have a right-angled triangle, or a side that you will need. So for this one, you would have to find the area of the triangle, and so that would be using Heron's formula. So if you remember, that's the square root of side take A, or not side, sorry, S is half the perimeter, S take B, and S take C. Also remember that to find S, it is just half of the perimeter. Oh, no, hold on, sorry, I forgot the plus. A plus B plus C in brackets. So you add together the 3 sides and then half it. You can also divide by 2 instead of multiplying by half. So this will find you, those formulas will find you the area of the triangle. Then you would use area of a trapezium, which is half A plus B, which are the 2 parallel sides every time, multiplied by the height. Once you've actually found those two, the area of those 2 shapes, you would do your total area equals area of triangle. Oh, that didn't work. Area of the triangle plus area of the trapezium. And underneath you would just add together. and come up with a final answer. You need to remember to set it out just like the last one, showing the different steps, what you're finding each time, and using rules and subbing in, following those correct CAP procedures. At the end, you would need a concluding sentence. So if you imagine this is a parcel of land that someone is buying, and do remember that sometimes you are asked to convert it into hectares. So what you need to remember to do there is write your conversion factor. 1 hectare is equal to 10,000 square metres. And if your parcel of land, when you add it all together, is 60,000 square metres, so we could just write 60,000 square metres is going to actually be equal to 6 hectares. And how do I know that? Because what I did was divided by 10,000. I divided by my conversion factor. Now, how did I know to do that? Because see how I've got square metres on this side and it's a large number, hectares on this side and it's a small number. So if I'm going from this large to small number, I'm going to actually make the number smaller, and to do that I divide. So if I was actually going from hectares to square metres, which is straight under, the same, see how these have swapped sides, hectares and metres squared, but if I was going hectares to metres squared, I would be multiplying by my conversion factor, multiplying by 10,000. Do make sure that's set out, because this is a K1, can also be M1 if it's in a math question. There's your K2. Over here shows communication can also go towards your K2 mark, K3 at the final answer, and then that would inform your M3. Okay, so actually I'd like you to have a go at doing this one yourself. If you get stuck, you can ask me in class and I can run through it with you. But have a go at this one, and then you can go through the questions on the area of Polygon PowerPoint.